Hi folks, and welcome to Conics 3. So in this tutorial we're going to be having a look at putting something called a tangent onto an ellipse and a circle. And then after that we're also going to have a look at a point of interest about an ellipse and a circle as well. Okay, so we'll kick it off here. So I've set these guys fairly small. We're going to be drawing two ellipses today, a circle and a semicircle down the bottom, or you can draw a circle if you want. The major axis across here is 100 millimeters, and the minor is 70 millimeters from top to bottom. So we'll start off there and we'll go ahead and we'll draw our minor axis, our major circle, sorry. And now we'll draw our minor circle. Get our 60-30 set square and we'll divide up our circle. Now we have 4 points here straight away. And now let's find the 8 other points. So where the dividing lines hit the minor circle, we'll do these little horizontal lines. And where the dividing lines hit the major circle, we'll do these vertical lines. And now we have our 8 other points. So I always advise to start off when you're doing an ellipse and do the flat parts first. So we don't want these guys ending up in points. And then we just draw them lightly till we're happy with it. Now, when we move it down, we'll go a bit heavier. So there we have our ellipse drawn, okay? And just before we go talking about the tangents, I'll draw in the circle as well. So make it a decent size. This is radius 50 I'm making mine. Now, a tangent, what is it? Well, sometimes when you're looking at a question, and I'll show you an example in a moment here of a helmet. And you can see in this question, which we will be doing in the future, we have half an ellipse A, B, C. And this line here at the end is an example of a simple tangent that could be on an ellipse, okay? And when you see that, you will see that in some questions, you could have part of an ellipse or a full ellipse, and then there might be a line joining on to it like that. So a tangent is a line that touches the curve at one specific point, okay? So a very simple tangent for me to draw here would be to draw a tangent at the end here on the vertex, okay? That could be a tangent there. It is touching one point and one point only, okay? So put in a tangent there. Another easy place to put a tangent would be down here. It'd be very easy to find that guy, okay? That could be a second tangent. Now, more than likely, you know, as you go forward doing your drawings over the years, you will be asked to get tangents in different places. Not as handy as that or that. So let's say you've a point up here on the curve, and we'll call it point X, and we need to put a tangent onto X. So what do? Well, you will have to find your focal points first. Now remember, we said the last day, half the major axis, put on the top. If you swing there, you'll get your focal points F1 and F2. Now, what you need to do after that is you need to draw a line from the focal points to that point X, okay? Then get your protractor or your compass, put it down, and what we're going to do is we're going to bisect this angle. So I'm going to draw an arc there, and where from here I'll swing another small arc, and from this side we'll swing another small arc, and where the two arcs cross, I'll just do a bit heavier there, so the two arcs cross there, that gives me the bisector of that angle, okay? That bisector is called a normal. And the good thing about a normal is a tangent is always at a right angle to a normal. So down there, your set square, and you can draw in that tangent. So just to go over that again, we found our focal points, join both them to X, bisect that angle there between the two purple lines, and we got our normal. And then the tangent was always at a right angle to that normal, okay? Now let's have a look at a tangent on a circle. And this is much more straightforward. Again, I pick a point here, we call it X. Put a tangent onto that. So what you will do is you'll draw a line straight on, going out through X, okay? Let that be our normal. And here at X, we'll draw a line perpendicular to the normal. And that's your tangent. Bit of work with the ellipse, very straightforward with the circle, but you will need to be able to do these as you go on to progress through the questions, okay? Now the last piece is a piece of factual information which will also help you solve questions. So I'm going to stop talking, go ahead, and I'm going to draw this now, and then I'm going to draw the circle over there as well, okay? So please draw another ellipse here, exact same size, and draw a semicircle over here. So now we have our ellipse drawn here, and we have a semicircle drawn over here. Now, before I show you this factual point of information, we need to find our focal points again. So set your compass to half the major, put on the top. There's our F1 and F2, okay? Now, a point to note is that you know the major axis here is 100 in this question, for example. But if we pick any point on the curve, I'll pick a point up here, call it J. if you join F to J and F1 to J, what you will find is they are the same distance as the major axis. So if I pick that there, that's 25, and this guy here is 75. Okay, so that makes 100. Pick another point, check it out. We'll pick another point here, we'll call it K. If I join K, F1 to K and K to F2, if I measure these two guys, this guy will be is 54, which means this guy here now will be 46. Okay, so it's just a factual piece of information. Any point on the curve is the same distance as going from both focal points is the same distance as the major axis. Okay, so all those are adding up to 100 there. On a semicircle, if you pick any point on a semicircle and you join the end of the diameter to that point, down to the side, what you'll find is that will make a perfect 90-degree angle. We'll try it out again. We'll pick another point, pick anywhere at all. And again, if we put in our set square there, we can see that is a perfect 90-degree angle. Okay. And so that's it, folks. I hope you found that useful. Take care. More videos to come soon.